Hi everyone. So today's lesson will be on exponential growth and decay. And as we've already talked about, an exponential growth function will look something like this, where the function is increasing as we move to the right on the graph. And an exponential decay function will be dropping as we move to the right on the graph. We have a couple of examples right here for you so you can think about why we would use exponential growth and exponential decay. And I'm going to do a couple of financial problems with you so that you can get a feel for how we would use these in real life. So first of all, let's talk about this formula. And this formula is used when you are making a single payment and trying to figure out how much money you would have in the bank after a certain amount of time, or the value of something as it would increase or decrease over time. Sometimes you might see it written with a subtraction sign here because for decreasing or decay, it would reduce the value. So let's get to these variables. First of all, the n on the left will be the new value of your item or money that you put in the bank or whatever after an indicated amount of time. N sub 0 represents the initial or starting value of your item or your bank account or whatever. R is the rate of growth or decay. And I want you to remember that we usually talk about a rate as a percent, but in calculations, we must convert that to a decimal. And to convert that to a decimal, we basically move the decimal point over 2 places to the left, or you can think about it as dividing by 100, and that means the same thing or does the same thing. T in this particular example will represent time, and it will be time in years. So the example that I have for you talks about the value of a car, and it says a car depreciates or, should be there's a typo there, or loses value at a rate of 20% per year. That's important. The original value was $20,000. So what I want you to do is I want you to model this scenario with the exponential decay formula. So here's the deal. The new value after a certain amount of time will be equal to the starting value of $20,000, and I'm just following this formula up here, by the way, on the top right. $20,000 times, gotta get my correct color here, times 1, and it says it's depreciating at 20% per year, so 1 minus 0.2 or 0.20 to the t power. And I'm going to clean that up just a little bit, because I know that 1 minus 0.2 is 0.8. So that's the formula that would represent the value of the car after however many years have passed. And that exponent would be the number of years. So if you look at letter B, it says to calculate the value of the car at the end of 2 years. Now, my suggestion to you is not that you just drop a 2 in there. My suggestion is that in your calculator, you put y equals 20,000 times 0.8 to the x, and then pull up your table, because that will show you the value of the car after 1 year, 2 years, 3 years, 4 years, and so on. And sometimes we'll ask questions like, how many years will it take for it to depreciate to less than $5,000, and you would kind of have all of your values right there. So hopefully you put that in your calculator, and hopefully you saw at this rate of depreciation that $20,000 car that you bought would only be worth $12,800 after 2 years. So let that sink in. Think about what that means. Each year you're losing money off the value of the car, and the chunk of money that you lose is a percent of the value of the car that year. So you actually wind up losing smaller chunks of money each year. Okay, so let's move on. And this example is a formula that we use for compound interest. So this is really like a money formula, okay? And we're going to identify our variables, and then once we go through this example, it should make a lot of sense. So very similar to the previous problem. A, it will be the new amount of money. Okay, so the new amount. And P is what we call the principal. And that is really the amount of money that you put in the bank at the beginning. So that's like the original amount or initial amount. Okay, this is a specific example to, finances, so that's why we have these variables. R is the rate, just like it was before, percent to decimal, don't forget that. N is the number of times the interest will be compounded per year. And I'll explain that in a second. And T is time in years. So while you're writing that, let me explain that. Sometimes banks will give you interest every month. So the end value for that particular scenario would be 12. Sometimes banks will give it to you quarterly, meaning 4 times a year. So the end value in that case would be 4. Sometimes they'll give it every 6 months, so N would be 2. So that end value just represents how many times you're getting paid interest by whatever the account is that you have. Okay, so let's take a look at this problem. I'm going to keep the equation up there, and seeing that we're dealing with money, I'm going to start writing in green. We want to know how much Sabrina should invest in a money market account if she wants to have $9,000 saved at the end of 10 years. She's getting 6% interest compounded quarterly. So let's write some notes off to the side. First of all, the rate is 6%, so we know we're going to use 0.06. It says that she's getting paid quarterly, so our N value will be 4. And T is the number of years, so she's going to keep her money in there 10 years. So let's write the formula so we can substitute in correctly. And I want you to notice this R over N. What they're really doing is they're not paying her 6% 4 times a year. They're taking the 6% and they're giving her a fourth of that 4 times a year for 10 years. So, what do we have here? She wants $9,000 at the end of the 10 years. She doesn't know how much she should put in right now. She knows that she's getting 0.06% 4 times a year. So she's actually getting a fourth of the 6%. And she gets it 4 times a year for 10 years. You can clean this up a bit. Okay, first of all, nothing happens to the 9,000. Nothing happens to the P. In this case, we actually can do 0.06 divided by 4 and get a nice number. It's actually going to be 0.015. If that number did not come out exact, I would require that you put it in the calculator like this. But because it does, what we really have is 1 plus 0.015 is 1.015 to the 40th power. So what we're going to do now, I want you to just think about this because we don't actually have to write this number down, but what we're going to do is we're going to calculate this value right here. So in our calculator, we will put 1.015 and raise it to the 40th power. I get 1.814018409. I'm not going to round that. But what I'm going to do is I'm going to do 9,000 divided by that number. So 9,000 divided by the previous answer that is in my calculator. I'm not rounding. And that tells me that I get $4,961.36 as a p-value. Let's think about what that means. What was she trying to figure out? She was trying to figure out how much money she should put in the bank right now so that in 10 years she would have $9,000. So this really says that Sabrina should put $4,961.36 in to be able to save the proper amount of money. Okay? If anything changed in this scenario, that number would change. If the rate was different, that number would change. If the number of times she was getting paid per year was different, that would get changed. Or, of course, the number of years that she was keeping her money in. If that was less, she'd have to put more. If that was more, she'd have to put less. So everything is important. So let's turn the page and let's look at example number 1. What I want you to do is I want you to stop the video. I want you to fill in all the values up here, and I want you to try to do number 1. Then start the video and let's see how you did. Okay, so let's take a look at the first one. And the first one was a little more straightforward. We just had to solve for how much money we would have if we put $1,250 into an account that paid 8.5% compounded quarterly. So they're going to divide that into 4. And we were going to keep it there for 3 years. So you can do some things in your calculator. Obviously, you can put all this. Instead of putting 4 times 3, you should probably just put 12. That's a pretty easy calculation. But when you do it all, you should wind up with $1,608.75. Okay, so be careful with this. Have a great day, everybody.